So in the previous video, we have seen all the important concepts which are required in this activated sludge process. So once again, we'll quickly revise what we have seen. So the main important points that you should know before understanding the activated sludge process is the action of microorganisms for decomposing the organic matter. Okay, so you can just imagine that microorganisms eat the organic matter, that is organic matter acts as their food, and they convert this organic matter into a simple end product. This end product we call it as sludge or biomass. Okay, so the reaction I have given it below. So this is an aerobic reaction. Aerobic reaction means this reaction takes place in the presence of oxygen. So this is the main activated sludge process. The sewage comes from here, that is called as influent, first into the aeration tank. Okay, this is an aeration tank. Aeration tank means there is supply of oxygen here. So this represents here oxygen supply. So oxygen is continuously supplied to this tank. Now what happens is that microorganisms which are present in the sewage, they start reacting with the, we can say, start eating the organic matter, and they convert the organic matter into biomass or sludge. That biomass is slowly transferred to the next unit, that is secondary sedimentation tank. In this secondary sedimentation tank, due to this settling action, the biomass gets settled here. Now we have seen that this biomass or sludge, the diagram is like this. The sludge is having some coating of living microorganisms which is there. This coating of living microorganisms, we call it as active. Why it is active? Because it is living. These microorganisms are very active. So if these microorganisms somehow we are able to recycle back into aeration tank, the concentration of microorganisms will increase in aeration tank. As the microorganisms will increase, they will eat the food more quickly. That will increase the efficiency of removal of organic matter. Okay, so this entire process is been done in the activated sludge process. Remaining points I have given it in the previous video, you can just watch it. In this video we'll just going to see what are the various formulas which can be asked or which are given in this chapter, and how to find out those units. Okay, now let's start with the first one without wasting any time. So these parameters which is seen here, that in the previous video I have given this qyi. So once again I will write it down so that there will not be any confusion here, what is q, what is qe, and what is qw. So just write it down here directly, where q stands for wastewater 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 inflow rate, wastewater inflow rate, or we also call it as influent rate. Then the next one is yi. So this yi stands for influent bod. Then v stands for, you can just refer this diagram. See, this q we have done, the vi yi we have done. Now we are going to the v. The next one, the v stands for volume of aeration tank. Volume of aeration tank. Then this x represents concentration, or we can say mixed liquor suspended solids. See, don't get confused with the word. Okay, what is the meaning of this mlss? It nothing but it is a mass of microorganisms. Okay, this represents the microorganisms which are present. Next is qe. So this is effluent flow rate. Then ye, effluent bod. Then xe, effluent mlss. Then qu. So where is qu? See, this effluent we are done. Now this q we are taking. So this u stands for underflow. Okay, so this is underflow rate, qu. Then next is xu. So this is mlss in underflow. QW. It is the waste sludge flow rate. Okay, so this is the waste sludge flow rate, QW. And last is QR. So this QR is rate of sludge return. Okay, so why this sludge is returned back to the aeration tank? What is the requirement? To increase the efficiency. Okay, now so let's write down the main formulas which are present in this. So give the heading design parameters in activated sludge process. First parameter, it is food to microorganisms ratio, that is F by M ratio. So the most important parameter in this activated sludge process is this. Okay, so write down, it is the main parameter in controlling BOD removal. Okay, once again I am writing it here. MLSS represents what? It represents the microorganisms. Okay, and BOD represents what? BOD represents the food or organic matter. Okay, now if the F by M ratio is less, this means what? This means that microorganisms are present in more quantity. If the microorganisms are present in more quantity, then there will be more BOD removal. Now, so what is the definition for this? It is the ratio between mass of BOD consumed per day to mass of microorganism. Okay, so F by M, it is equal to, so write down this formula, Q into Yi minus Ye divided by V into X. So if in question Ye is not given, then you can directly take Q into Yi divided by V into X. What is Q, Yi, V and X? Everything is given in this slide. Okay, you just refer from there only now. So this is the formula for F by M ratio and this is the use. Okay, now let's move quickly to the next design parameter, that is called as mean cell residence time. MCRT. This is also called as solids retention time. It is also called as sludge age. Okay, so write down, so it is the average time suspended solids remain in aeration tank. Okay, so this time we are calculating it. What is the definition? So it is the ratio of mass of solid in reactor, that is aeration tank, to mass of solids, that is ml/ss, wasted per day, wasted per day. Okay, so mcrt, it is equal to, so what is the mass of solid in aeration tank? So that is v into s, v into x. What is the amount of solids or mass of solid wasted per day? It is calculated like this: QE into XE plus QW into XU. Okay, so most of these formulas are empirical only, so no need to go into the much derivation here. So V into X divided by, so we can just write it QW into XU. In terms of QE, if you want to write it, you can write it Q minus QW into XE. So this QE is the effluent flow rate, QW is the wastewater to the treatment. Okay, that is wastewater flow rate or waste sludge flow rate. So by substituting the values in this, you will get the value of MCRT, that is means cell residence time. Let's move to the next design parameter, that is volumetric loading rate. Volumetric loading rate. So this is also called as BOD loading or organic loading rate. Okay, so it is defined as mass of BOD applied, mass of BOD applied per day per unit volume of aeration tank, So volumetric loading rate, it is equal to Q into Yi divided by V. Q into Yi divided by V. So let's move to the next one, the next design parameter, that is efficiency of BOD removal. So this efficiency, it is denoted by nu, and this is equal to influent BOD minus effluent BOD by influent BOD into 100. The next one is aeration period. This is also called as detention time. So aeration period is calculated as, or you can say detention time, it is calculated as volume divided by influent flow rate. See, now the last thing that we are going to see here after this aeration period, this is super important in this chapter and questions can be asked from this. So this is called as sludge volume index, in short form SVI. Very important. Okay, so just write it down initially. What is the sludge volume index? So it is the space occupied in ml. It is the space occupied in ml by 1 gram of MLSS, by 1 gram of MLSS after 30 minutes of settling. From 1 liter of sewage sample. So what we'll do is, we have to take a flask here. So in this flask, there are some calibrations which are given to measure what is the volume. Now in this, we have to add 1 liter, 1 liter of sewage sample. So once we add this 1 liter of sewage sample, so what will happen? Slowly the sewage, whatever the suspended solids are present, or whatever the solids which are present inside this sewage, so they will try to settle in the bottom portion. So I can say the concentration is more in the bottom portion as compared to the top one. So whatever is the volume, or we can say whatever the space or volume which is taken by 1 gram of MLSS after 30 minutes of settling. Okay, so for 30 minutes, if we keep this sewage in this flask for settling, then the volume which is occupied by in 30 minutes by 1 gram in 1 liter of sewage sample, this is called as sludge volume index. Okay, so you just remember 3 important points here. First is how much time the settling is done. The settling is done for 30 minutes. What is the amount of sample that is taken? 1 liter. And what is, or how much gram we are taking? It is 1 gram of MLSS. So these 3 things you should know. So sludge volume index, it is nothing but space occupied divided by MLSS. Now this space occupied, it is measured in ml. The space occupied is measured in ml, and this MLSS, it is measured in gram. So the unit is milliliter per gram. Now the last one is very easy, you can just write it down. So it is called as a recycling ratio. So as we know, the sludge from the secondary sedimentation tank, it is taken back to the aeration tank. So the amount of recycling is we can say it is controlled by taking this recycling ratio QR by Q. So there is no such definition to this, you can just write it, the formulas here. Recycling ratio is QR divided by R. What is the formula? Formula is X divided by XU minus X. Now what is X and what is XU? So I have written it here only. X stands for mixed liquor suspended solids. XU stands for MLSS in underflow. What is meant by underflow? Underflow means when we are taking certain amount of sludge, then out of that certain amount of sludge from secondary sedimentation tank, a part only is taken for recycling, other is taken to the next treatment process, that is sludge digestion. The next processes are sludge digestion and sludge thickening. So let's say if we are taking 100% of sludge, or we can say 100 gram of sludge from secondary sedimentation tank, out of this 100 gram we are transferring 80 grams to aeration tank and 20 grams to sludge digestion, that is the next treatment process. Okay, so this is the formula, and in this XU, that is MLSS in underflow, it is calculated by 10 power 6 divided by sludge volume index. So this formula also becomes like this: X divided by, so instead of 10 XU, you can write 10 to the power 6 by sludge volume index minus X. So these are all the important formulas. See, from this chapter you have to learn these formulas because this is formula based chapter only. You might be thinking that there are many theoretical concepts which are present. No, don't go much into this theoretical concept. Whatever the points are required, it is already given in the slides. You just remember those points. The basic process you have understood about aerobic reaction. The only thing is that you have to learn the formulas and then solve the problems. Okay, it is completely a formula based chapter. So remember this, all the units which are there, and remember the formulas for each of the design parameters.